All righty. Next up, and our last official session of the day, we'll have the Hackfest Awards and wrap up after this. But it is Melody and April, and the title is Claude MCP Server for microM8. Apple II vibe coding and fun and frustration. And they're going to introduce and demonstrate a new MCP server for the Micro 8 that allows Claude to code directly in the Micro 8. So take it away, Melody and April.
Thanks, Jay. Hello, KansasFest, and welcome to our talk about using LLMs for retrocoding. I'm going to talk a bit about the recent progress of LLMs and their current suitability for creating programs on vintage computing platforms like the Apple II. Then April and I are going to do some demonstrations and talk a bit more about practical aspects. So here we go. The use of large language models has always been contentious, especially their disruption in creative industries and education, where they've upended the traditional model of examinations and research papers and forced more practical evaluations. These disruptions have caused a mixture of worry and excitement that they would be coming for the software engineers at some point. But they have struggled to become truly useful in programming, especially novel programming. This has much to do with their ability to actually reason. Even a year ago, they were really bad at thinking. But over the last year, this has changed somewhat. They're a little less terrible. This has changed due to three main factors: the scale and resolution of the model itself, the algorithm behind getting a result, which now iterates better in an attempt to refine a result and improve accuracy, and a larger context that allows for the insertion, or the amount of information that it can process, that allows for the insertion of large amounts of reference material, consideration of past history, and the ability to search the internet for information as required. All of that has begun to make them vaguely useful, not just for regurgitating boilerplate or cribbing from open source projects, but to actually define and write original code. And so as a result, companies like the one April works for and many others have begun to use LLMs in a limited way to write things like configuration and in-house tools, despite the fact that the intellectual property status of their output is still largely unsettled. But for internal use in creating infrastructure code or tools, there's little concern about that, and so where practical, they are beginning to find use. But they are always a tool, not an oracle, and so it does and probably always will need some talent and a great deal of understanding to use them properly, like any other tool. A great tool needs a great craftsperson, always has, and probably always will. Anyway, so it looks like LLMs may be here to stay, in whatever capacity, and assuming they continue to improve, will continue to encroach into other areas of software development. But as I've alluded to, it's not just their future technological improvements that will determine their success. There's an additional factor to consider. When the Apple II originally came out, programs were rather crude because programmers were new to the Apple II. Reference material was scarce, and techniques were primitive. Over time, they improved. They got better, not because the Apple II changed. Well, it did, in a sense, but in terms of, but because programmers learned how to utilize the hardware and ROM code better than they, were originally. They developed understanding techniques and strategies to leverage what they had as best they could, and this learning was continuous over time. The situation with LLMs is largely the same. They are a new technology that we have barely begun to learn how to properly exploit. Currently, we want to treat it like a rock and just smash stuff with it with obvious results, but you can't use it like a rock. If you ask it to make a game with all of the associated mechanics in a single prompt, then it's almost certainly not going to work, and attempts to fix the code after the fact are going to fail because bad code is all there is to work with. It becomes the fruit of the poison tree situation, where it goes back and attempts to fix something that's irreparably broken, and so you get stuck. And so you have to learn to be incremental and patient, provide all of the necessary information, and really think about how you engineer your prompts to get the best results out of the LLM. And especially if you want to use them to write programs for the Apple II, which LLMs know very little about. It's not exactly like their corpus, has a wealth of information about the Apple II in it. So why would we want to use LLMs in retrocoding? Well, there are a few areas they can assist with. One, writing new code. It's fun to code, but it can be tedious and frustrating. And I know a lot of us have a sense of reward when we make trivial mechanic work, especially if it was buggy. But most people don't enjoy that sort of sadomasochism. but they would still find enjoyment making something, out of their imagination work, however small. And it's certainly easier to make something work on a retro computing platform than on a modern computer. Unless you want to write it in something like Scratch or Turtle Spaces or something, which we'll get to later. Debugging existing code, theirs and ours. So even if the code itself is written by hand, they can still get us out of a bind, especially if you use an MCP so that the LLM can control the emulator itself, which is something we will get to shortly. Debugging is a pain in the ass. It takes a lot of time. Really stubborn bugs. You can develop blind spots, and if you're a solo programmer, then you can get stuck for days and weeks, and eventually just find like the bugs right in front of your face. If an LLM can review the code and prevent us from spending hours and days doing that, then who can complain, really? Learning how to code with the Apple II architecture. Most of us are tinkerers at heart, but learning things like assembly is a bit of a task, given that you have to do a fair amount to get it to do anything of substance. Getting the LLM to write some, basic boilerplate code and stuff, and simple stuff even helps us to learn about assembly. But more importantly, it helps us learn about the architecture, memory maps, zero page, limits and jump addressing, all of that stuff. So as an educational tool, it's quite useful. On that note, too, just in general, LLMs can actually be a really good educational tool from a constructivist perspective, assuming you use them to actually create something substantial and sophisticated kind of gradually and organically. It's one thing to use it to just barf out some text or a single throwaway image, but engineering a prompt, to get precisely what you want can take a lot of trial and error and iterating and so on and so forth. And you start to develop an understanding of how and why you need to phrase things in certain ways to get the LLM to do what you want, which is a lot of thinking about its way of thinking. It's thinking about thinking. It's like a really fancy logo turtle. It will draw what you want it to draw, but you have to tell it how to draw it in really fine detail if you want to get what you want. Otherwise, it'll give you what it thinks you want, which is probably not what you want. Also, many of us learned how to code debugging faulty magazine listings because it was our only source of new software. So once you learn fairly quickly that if the LLM starts spinning, you're going to need to go in there and actually review the code yourself. And even if your knowledge is limited, sometimes it becomes fairly obvious that it's stuck in a loop or that the data is in the wrong place or whatever. And so you're gradually learning in that same way that we did, trying to fix bugs in misprints. Yeah. And so, you can, help with program flow and begin or redescribe an algorithm. Sometimes, if it's doing something and it's not working, you can tell it to do a different method, but you have to tell it kind of more specifically what kind of different method you want it to do. So if its way of using a ROM routine isn't working, you can tell it, don't use a ROM routine, plot that line, manually and stuff like that. But you kind of need to develop that understanding. So it really becomes a situation of playing with it like anything, trial and error. There's a lot of, can it, barf out a game one off? No. Will it be able to? Probably not, but it's learning how to use it. All right. And so over the last several days, I've been attempting to write some games using Grok 4, and it's been interesting. We'll look at some of my experiments and see how they went. Some of them worked, some of them didn't. And then we'll go over to April, who's been using Claude Code and Cursor. And we'll see what Claude Code does when it can directly access our microM8 Apple II emulator using the Model Context Protocol, or MCP. So first we'll look at creating a new coding conversation. With modern LLMs, luckily we don't need to provide all of the information with every prompt. Their context or how much external information they can process has grown over time, and they can reference an entire conversation to a point. It will start to compress it and throw stuff away. And that can be a bit of a problem. So conversations can only last so long. And so if you're not done quickly, you'll need to start a new one. Bring in your last working code from the previous one, and then reseed it with all of the information you want it to know. Also, to bring the LLM up to date. Also, conversations are seeded with a certain amount of randomness. And so if things aren't going well, you can benefit by starting a new conversation and having another whack at it, because that sort of weighting will direct what the LLM does in certain situations. So if it keeps banging its head against the wall, creating code that has a particular bug in it, starting a new conversation can actually get it doing something else. So for a new conversation coding with Apple II Merlin assembly, you should probably provide it with a bunch of information about the Apple II, which has a lot of esoteric idiosyncrasies that have to be taken into account. First, there's some general things that you want to tell it. Things like, for each change, only deal with the immediate issue, because sometimes it'll decide to, when it's reviewing the code, to go and change something, change other things that it's all of a sudden decided it doesn't like anymore. And you don't want it to do that. You should also tell it to and say, do not revisit issues discussed earlier, unless the current change can create a regression. You'll want it to analyze, formulate, and describe an approach to the change, not just do the change and not tell you about it, because then it's like, if it's broken, it's like, well, what did you do? I don't know. So, and then you want to tell it to implement the approach, don't deviate, and if it has concerns, it can note them, and deliver the change code and the concerns. You should tell it to comment everything. If you tell it to comment everything, as you'll see in the code, then it tells you what every bit of assembly does, which is really useful from a pedagogical standpoint, because then it's like, oh, it goes here, it does this, it blah, 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 blah. It's very educational. Tell it to, Grok in particular, sometimes it puts stream of consciousness thoughts in the code. It'll be like, you have the code, blah, 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 blah. Oh, wait, maybe I should do this instead. Blah, 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 blah. Oh, no, that won't work. and so you kind of have to go, sometimes you have to tell it to remove that. And if it's uncertain about something, to ask the user, because it'll make an assumption and you don't necessarily want it to do that. Okay, and then after that, then you'd want to tell it Merlin specific things. I'll get into that in a second. I'm just going to see if I can share my screen. Share screen. Hopefully. Screen 2. Share. Yes. Okay. Okay, so you start off the prompt. You're an Apple II Merlin assembly code programmer. You're developing a low-resolution breakout game. Paying attention to the following: outline a strategy for writing the code of the game. For each change, okay, those are the things we just talked about. Return output in a code block, because sometimes it won't. Indent and use org, blah, blah, blah. It seems to not indent org. And at the top of a Merlin thing, you need to indent it. Consult the memory map. Use semicolons for comments, blah, 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 other stuff. Now I put an introduction to Merlin assembly in the prompt, and 652 opcodes, the 652 addressing modes, because sometimes it'll try to use ones from other processors. description of memory areas, blah, 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 practical tips and examples. Anyway, and it's just stuff that I've added in. Now, April will talk about using Claude code. You can actually put little files, like you can actually grow files that have this sort of information in it. So this is really just for using online LLMs. So we're going to see what it thinks. So we're going to start with, you are developing a low resolution breakout game. Pay attention to the following, blah, blah, blah. Okay, outline a strategy for writing the code of the game. So we'll let it go off and chew on that for a minute. Okay, so what we're using to compile and execute the code is something we developed. It's a Merlin assembler editor. It uses our Cyanide web-based editor, WebAssembly based editor. And it, so you basically, you paste the code into here, and then you can assemble it and then execute it. So this was a game. I was sort of working on an infinite scrolling jumping game, and I just kind of wanted to start with some moving squares. So this is a similar prompt, and then so this was the first output, and so I copy it, and then I go into Cyanide, and then I paste it. That URL is paleotronic.com/Merlin+. Okay. And so this is the code that it generated. It says assembly language for scrolling rectangles, because we need to work incrementally. And so I want to create a game where you jump from building top to building top, or you fall in the hole. But so we're going to start with scrolling rectangles, which is effectively a building. It's been specified to create them of random width, but the same height. First, let's see if the code assembles. It does. It's in the wrong place. The 768 is not a great place. We'll assemble again. 2048. We'll execute. Okay. And so it has managed to create the blocks, which is good. Now I wanted it to have, so I'm like, hey, good, changed org to $800 and place 10 pixels of black between each rectangle. Fine. So let's try that. Assemble. Okay. Oops. We're called 2048 now. Execute. All right. And so we have our gaps between the buildings. Good for it. That's a very, very wide building. Very wide. Okay. All right. So keep going. Blah, 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 blah. And, and it does. It comments everything. So as you notice, it's like switch your graphics, set full graphics, set private page, blah, 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 return, blah, blah, blah. So you can follow the program flow through, even if you're not super familiar. Okay, so now let's add 2 pixel wide and 2 pixel high white square that occupies X 1920 and Y 2627. Fine. Which is going to be our player. Oops, didn't like that. So, impossible to decode address made for instruction, blah, blah, blah. So to begin with, I'm personally not gonna do it. I'm just gonna paste that in, and then it'll think about it. Blah, blah, blah. The code shows CLC ADC at 20 with a tab. Okay, well, anyway. It's written on one line without a new line combining CLC and ADC, and so then it's like, oh, I gotta fix that. All right. Oops. So copy that. Assemble and execution. Okay, so I got my player, but it's in the wrong place, and because of the scrolling, it's got a trail, which is not quite what we want. Okay, so we'll grab the player. Please move the white square to Y2122 and ensure ensure that it does not bleed to the left as the screen scrolls. Oops. Call 2048. Oops. Execute. All right. And so this is as far as I've gotten so far. So next would be putting in logic to detect whether or not it's black underneath in this area, and if it is, then the player falls unless it's jumping, and so then you have to put a key press in and blah blah blah. But there are other things. So this conversation started out being one game and turned into another game, and I think I blew out the context window because it's kind of stuck in a bug now. It started out being, oops, it's chopped off the earlier context, which is probably why it's not doing what I want anymore. I should have started a new conversation. Okay. Oh. Which one is this? We're still in the... Okay, I'm running out of patience. Oh. I was hoping to get back to the simple one. Oh, okay, there we go. It failed. And we're looking... Okay, so... Did that work? Okay. So this is just a simple, asteroid field scrolling one. It had some initial issues, but it figured it out eventually. And so you can use the J and K key. This is prior to checking for collisions, but it took about 5 prompts to get there, which isn't too bad for starting with something. So this is the most sophisticated thing that I got to. This took actually about 3 different conversations. That's why this is Bird Game Part 3. And about 100 prompts. This is also my Hackfest entry. So it started out with the flapping bird. And so that took a few prompts in order to get, well, first to get the bird flapping and then to get it moving around the screen. And then I had to add the player turret to it. I added the egg bombs. And then we had to add the collision detection for the live. Well, add the lives and the collision detection for it. And then add a laser. And you have to do these incrementally, so you add the laser first, and then don't worry about it registering hits or anything like that, and then add the hits afterwards, because if you try to do more than one thing, it will invariably screw it up. And originally it was full screen, so then we had to refactor it for split screen so that one could have a score counter and a lives counter. And it had some issues with the text page. This is actually an Apple IIe emulator, so originally Vibe Vulture was in mouse text because it was using the wrong character set. And so, yeah. And so then figured that out. And so that's not bad for, I think I've probably put about 4 or 5 hours into this. But now I mean, if I was experienced with assembly language, could I have coded this in 4 or 5 hours? Yes, probably, but I'm not experienced with assembly language, so having kind of this working relationship, you're you are able to get somewhere. What else do I have here? So this was a Towers of Hanoi game. So to draw the towers, so I started with drawing the towers, and the program crashed, probably because it was trying to use the V-line routine badly. So then the last thing I had was that all 3 lines were being drawn on Y0. So let's see what happened there. It compiles, so that's good. Oops, I'll do a reset. Try executing again. No, didn't fix it. All right, so I'll have to look a bit more at it. Okay, so I think that's enough for examples here. Oh, this sine wave one. Oh, wait a minute. Is that the sine wave conversation? No, sine wave. Oh, there it is. Okay. Oh. What's going on here? I was thinking. Oh, there it is. Oh, okay. Did we get to the end? No, it's still. Okay. Okay. Copy. Okay. So then you learn, like, for sine waves, right? It uses a table because that's just easier. It's stuff like that. But, or oops. Interesting. Okay. And so you can create some interesting stuff. But my tips are: be very incremental. Make sure it has the information. It will sort of learn off of itself in a recursive loop if the context gets too large. So you will have to start new conversations to remind it of what it's doing and what it's done. Also, analysis doesn't hurt. You can tell it at the end of the conversation if I'm like, we need to move this to a new. We need to move this to a new conversation. What would you like to tell yourself about the current project to make it easier to continue? And it will go off and think about it. Now, this was our breakout game. And it actually did create the game. I don't think it was supposed to. No tools are needed at this point. It's all about structuring, and then it created barfed out in assembly. Oh, okay. Oh, there's no code here. Okay, so it created the code, but it created basically a structural document. Anyway, so then one can start going through and iterate, refine. Yeah, okay. All right, so I think I will hand this over to April now, so she can talk about Grok. She can.
Oh, Claude.
Yeah, Claude. Yes. Sorry. Okay. So I'm going to.
That's all right. It's been a long weekend. Okay, so I better share my screen. Oh, yeah.
Sorry. I need to. Did my screen sharing go away? Yeah.
It did.
Okay, good. All right. So you're on then.
Yep, I am hopefully going to be sharing my screen in a second. Okay, so yeah, I'm going to be talking about MCPs, which I'll explain what they are. So I've been using Claude Code, and also I've been kind of working on microM8, our Apple II emulator, to see what we could do to kind of integrate and share context with an LLM. And so that's actually done by an MCP server, which stands for Model Context Protocol. So you can think of it as a tool that provides information and even the recipe for how an LLM can query information about context in something. So in this case, it was microM8. And so I wanted it to be able to interact with the emulator and also be able to kind of see the screen and get the state of things. So I've got Claude set up here. And what I've done is I've added a flag to microM8. It's not released yet, but it allows it to start in MCP mode, which allows Claude Code or an other tool that can interact with MCPs to kind of work with it and interact with it. So I will start that up. And so this one's actually using a standard input-output bridge, which is why it starts the emulator up automatically. And so you can see that microM8 is running. And so the first thing I'm going to do is, well, the first thing I realized we needed to do was be able to insert a disk. So let's do that. And so I was thinking about it, and bingo, it's put the disk into the drive. And you can actually see here on the screen, it's actually called an action insert disk on the microM8 MCP server. To do that, it says it's been inserted successfully. And so the next thing we're going to do is ask it, what is on the disk? And try our luck with this. And so at the moment, it doesn't read them directly, but it knows, and I'll explain about the context file, but it's got a file called Claude.MD you can put in the current directory that tells it how to do things. So it's aware that the catalog command exists. And you'll see there it's actually paged because there's more than a screen's worth of output. So I'm going to see if it knows that it needs to hit the space bar. And it's forgotten to. I'm going to tell it. Okay, it looks like it's sent character 32. It's got the rest of the listing. Okay. Okay, and you can see that it's actually returning the screen output to it as it does that as well. And you can actually kind of hit a key and expand and see what context it's got, but it's able to read the screen, which is important for being able to interact. So similar to what Melody's been doing, I have been kind of playing around with getting Claude to interact and trying to create programs. And I saw someone mention about like Applesoft in the chat. So we're going to get it to try to write a text adventure in Applesoft. So let's just try and do that. I'd like you to write a text adventure and Applesoft Basic. You can be creative up on the theme, but should involve retro computing. Okay. And so it's going to chew on that for a second. It says it's going to create a text adventure about exploring an abandoned computer museum. And so one of the other things I've done is I've given it the ability to access memory and also decode the Applesoft Basic in memory, and also to generate new tokenized basic and put it in memory. Initially, I had it typing by hand, and we would be here for a couple of hours while it slow keyed everything in. But that this is faster, but let's see how it goes. So with Claude, it'll just be saying something like hatching or flibbergibbeting while it's working on it, and so it's working on generating it. I haven't really given it that much knowledge on Applesoft. It is relying a lot on stuff that's kind of in the model itself. Though you can let it query online resources as well, and you can put information into the Claude.md markdown file as well. So one of the things Claude Code does, is it creates a to-do for everything. So it's saying it's designed the text adventure game structure and map, and it's busy writing the Applesoft basic code for the adventure game. And so then its third item, which we'll see how it goes, is to test the game and fix any issues. And it's writing a lot of game. But yeah, in the meantime, I'll just kind of explain about the MCP. So it's almost an additional service that starts. Oh, okay. So, that's the other thing too. It's permissions based, so it will ask you for permission to proceed with a new task it hasn't done before, and you can do one at a time authorization, or you can say, "Yeah, I'm going to trust you to write Applesoft into memory," which I may end up regretting, but let's do that. And so it's written 4407 bytes of tokenized BASIC to memory. Okay, so now it's typing run. Okay, Retro Computing Museum Adventure, the year is 2024. Okay, well, that's when its model was probably built. Okay. And so it's actually started trying to play the game that it wrote. It's figuring out what to do. But essentially, there's a whole host of functions in the MCP. So it can look at the screen. Claude actually has image recognition as well. So if it's a text screen, it can use Get Text Screen tool to look at that and just get the text. Otherwise, it can effectively get a PNG screenshot of the screen at runtime and analyze that to see if the things it expects are on the screen. Okay, maybe it's expecting me to do this then. Okay, that didn't do anything. I'm going to try West. Okay, that's not going anywhere. I'm going to ask it, what are the commands for the game? It typed help into its own program. Okay, now it's decided that it wants, oh, it seems to think it has got a help command, so it wants to. I think it tried to break the listing, but it didn't work. This is a technical demo. Okay, so it's looked at the code. Okay, it thinks it's actually doubled up on line numbers. So at the moment, it is trying to fix its code.
Maybe trying to choose a number game.
Yeah, that might have been an easier start.
Yeah.
Actually, let's do that. Otherwise, we might be here till Christmas.
As I was saying, I mean, it's a bit rough to try to get it to create an entire game.
Okay.
In one go.
I'm just going to say, let's instead try a simple guess the number game. Okay. So it's going to create a Applesoft Basic Guess the Number game. There's probably less that can go wrong with this. We'll see.
Yeah, and then ask it to play its own game.
Okay. Number between 1 and 100. Okay. Okay, you're going to try. Okay, it's trying 50. That's kind of where everybody starts, I guess. Too low. All right. Well, so far it's written code that's actually appears to be working, but we'll see.
It's a little bit too slow to play Pac-Man, but
yeah, it does have to think a lot. So you're not going to be kind of and process input and kind of like poll for screen state, that kind of thing. So it's not going to be playing any live action games. But from a standpoint where it can actually try to test the things it writes, that's one of the benefits of the interactivity. Okay, got it. 28 was apparently the number. Is it going to play it again, or has it had enough? It decided not to.
okay. Can we quickly do guess the number game in assembly and get it to compile it and try to run it?
Oh, okay. we can try it.
Or maybe just do hello world in assembly and get it to compile it and run it.
I'm just going to tell it to save the game to disk. Okay, it's done that. Okay. See, now it's checking the disk to see if it saved it. Let's see if it remembers to hit space. Okay, good. It did.
Remember to tell it to put it at $800 or something.
Yeah. Okay. And so one of the other things we've done here is to the same assembler API that we're using for the online assembler. We've allowed the MCP to access as well, so it can generate assembly code and then assemble it and then put it into memory. Yes, you will find it does spend a lot of time thinking, so it's still working on it. Okay. It's not War and Peace, Claude. To be fair, I have basically just said write it in assembly, so we'll see how it goes. I mean, context being everything, one of the things this doesn't supply is information about 650 assembler. So again, a lot of that's being inferred from its model or any resources you can kind of give to it via the Claude MD file,
Yeah.
or online searches if you let it do that.
So you can take all of the information on the 6502 and Merlin assembly and the Apple II architecture and stick it into one of those MD files, and then it will use it when it goes off to think about things. Oh, there it goes. It got don't know about that.
Yeah, we'll see. We'll see what it's going to do
That
here.
doesn't look like Merlin. I think you needed to say Merlin, but we'll see.
It's complained. So the dot byte directive. Yes,
Yeah.
I did. I will give it a hint here. Use Merlin syntax. I did not do that up front.
And maybe we should move on to the next. While that's doing that, do you have turtle spaces still open?
I do. So while it works on that, let's just switch across. Actually, it's got its picture.
Yeah.
We were working earlier on seeing if we could get Claude to use. So with Turtle Spaces, our logo environment, I've done a similar thing, and it was implemented this morning. The integration, similar concept to the microM8 one. So it can see the screen, it can write procs in logo, and we were trying to get it to see if it could draw a cat. And well, we did get it to draw a house initially. It's struggling a little more with the cat, but this is after progress, and Melody had been kind of nudging and correcting it and telling it to be more critical of its output. And you can actually see it thinks it's got it perfect. And you'll find that with LLMs. So they'll quite happily say, oh, yeah, I did this thing. It's totally correct. And then you look at it and you're like, no, it's not.
Yeah, tell it to critically analyze the image.
Yeah. So yeah, telling it to be critical, especially with like Claude, can be helpful. So it gets okay. It says it sees several issues.
Yeah, it's very optimistic, but there are ways to force it to be more critical.
Yeah, and you can see again, it's created some updated to-dos there to work on. And so while it's looking at that, I'm going to flip back to our microM8, and oh wow, it's still working on the Merlin rewrite.
Well, we're hoping to get these MCP changes out in the wild probably by next weekend, and so I'll probably post an article on Paleotronic, but I'll also post an article on. I'll post an update in emulators on the Discord, basically letting people know that it's out there, and so if you want to play with it, then you'll be able to play with both. Turtle Spaces, which is based on Apple logo, so it's interesting from that perspective. Or using microM8 to write AppleSoft or compile Merlin directly into memory. Yeah, and I think maybe we should wrap it up. Oh, did it finish? Oh,
no, it's still working.
Yeah,
it's having time.
Yeah, you got to give it some more information. That's okay. Anyway, I'll provide with the article like some downloads of information that's been working for me.
All right, guys, this was awesome. So I'm happy to see that it hallucinates on 30 or 40-year-old code too. So
yeah, it consistently hallucinates. I think we can say that.
Yeah. Well, we're a little skosh over. So if you want to go into the Discord channel, I think there's some comments there. There might be a question or two. So, but thank you very much. This was very, very cool, and we can hardly wait for it to be published so we can take a look at it.
Awesome.
Thank you.
Thanks.